Today we're going to learn about applications of L'Hopital rule in calculus. Let's say we have a problem like this. Solve A, the limit as x approaches 0 of x cubed over x squared, and B, the limit as x approaches 0 of sine of x over x. So before we get started, let's first go and see what happens if we just direct substitute x equals 0 into both of these. Because we know these are both limits as x approaches 0. So in the top one, if we substitute 0, we get 0 cubed, which is 0, over 0 squared, which is 0. So let's write that down. We get 0 over 0. And then in problem B, when we direct substitute, we get sine of 0, which is, as we know, 0 over 0. As we can see, these are both in definite form. What that means is they're divided by 0. So these aren't the actual answers. So these aren't the actual limits that x approaches. Or these aren't the actual values that when x approaches 0, the function gets closer to. So how do we solve that? Well, we remember what L'Hopital's rule is. L'Hopital's rule is states that if f of x over g of x, if the limit as x approaches 0 or infinity, or 0, if the limit as x approaches some value is 0 over 0, infinity over infinity, or negative infinity over infinity, we use this rule. The rule states that if any three of those conditions happen, then the limit is equal to, so the limit of that value is equal to, so the limit of f of x over f of g, or g of x, sorry. So if the limit of f of x over g of x approaches infinity, negative infinity, or infinity over infinity, negative infinity over negative infinity, or 0 over 0, then this limit is equal to the limit as x approaches some value of f prime of x over g prime of x. So that's what we remember what L'Hopital's rule is. So let's use that to solve problem A. So in problem A, we have x cubed over x squared. So let's take the first derivative of this. So we know this is equal to, we can erase this now. So basically, L'Hopital's rule states that if the limit as x approaches some value is infinity over infinity, negative infinity over negative infinity, or 0 over 0, which are all in indefinite form, then that is equal to the limit of the derivative of the numerator over the derivative of the denominator. So let's take the first derivative of this. So we know that this will be equal to the limit as x approaches 0 of the derivative of x cubed is 3x squared over 2x. As we can see, when we plug in 0, we still get 0 over 0. So what do we do? Well, what we do is we take this again, because once again we get 0 over 0, which is one of those three conditions that must happen for L'Hopital's rule to be used. So because one of those is happening, which is 0 over 0, we can use the rule and take the derivative again. So this is the limit as x approaches 0 of 6x over 2. As you can see, we have a 2 in the denominator. So when we plug in 0, we're going to get 0 over 2, which is equal to 0. Let's write this in black. Is equal to 0. Now let's move on to problem B. So in problem B, we have sine x over x. Sine of x over x. So once again, if we plug in 0, we get 0 over 0. So what do? Well, we use L'Hopital's rule again. So this is equal to the limit as x approaches 0 of the derivative of sine of x is cosine of x over the derivative of x is 1. So when we plug in our values, we have cosine of 0 is equal to 1 over 1, which is equal to 1. So once again, the answer to problem A is 0. So the limit as x approaches 0 of x cubed over x squared is 0. In problem B, the limit as x approaches 0 of sine of x over x is equal to 1. Today we learned about applications of L'Hopital's rule.